Example number 3, solve. What you're noticing here is that I'm using the word solve, whereas in the previous videos, previous to this being in 7.4, 7.3, 7.2, and 7.1, I've said simplify. What's the difference here? Solving means that you get a specific value of x for a specific expression, or for a specific relationship. So this one says solve, why? Because we see an equal sign, so that means that we're solving for x. In this case we're solving for x2, and I think in the other one we're also solving for x. So first things first, this may seem strange, but we want to find that lowest common denominator again. And let's use our sweet 7.4 skills. We know that the lowest common denominator here is x plus 2 and x minus 3. So then x, the non-permissible values, x cannot equal negative 2 and it cannot equal positive 3. What I want to do is I want to multiply each side of the equation by the lowest common denominator. So I'm just going to put this in the middle. Negative 3 over x plus 2 equals 2x over x plus 3. What I'm going to do is I'm going to put brackets around them because I'm going to make this really, really clear what I'm doing. I'm multiplying it by x plus 2 and x minus 3. On this side the same thing, x plus 2, x minus 3. This is different from our previous question in 7.4, where we would multiply by this over this, right? We would multiply by, say, x plus 2 times x minus 3 over x plus 2 minus x plus 3. That's because it was an expression. The only thing that we can do is multiply by 1. But since this has an equal sign, it's an equation, what you do to one side, you can do to the other. So really, we're just multiplying each numerator, okay, we can even put this all over 1, by this lowest common denominator. So I'm going to cancel this x plus 2 with this x plus 2. And then on the other side of the equal sign, I'm going to, oh sorry, did I write this down wrong? Oh yeah, this should be negative. Very good, sorry about that. Okay, I can cancel this x plus 3 with this x plus 3. So I have minus 3x plus 9 equals 2x squared plus 4x. I don't want to make this negative, so I'm going to take everything, I'm going to add 3x to both sides and subtract 9 from both sides. So that's going to be 0 equals 2x squared plus 7x minus 9. Two numbers that multiply out to negative 18 and add up to 7. We're talking about positive 9 and negative 2. I'm just going to hurry down to the solution here. So we get the factored version of this to be x minus 1 and 2x minus 9. So we have the solutions of x equals 1 and 9 over 2. They're both going to be, oh sorry, this should be positive here. Okay, so then this becomes negative. We look at these solutions, and to verify, we're just making sure that none of the values can't be a non-permissible value. 1 is 1, not negative 2 or 3, so we're good. Negative 9 over 2 is negative 4.5, which is neither one of our non-permissible values. So, then, solution, solved. Let's move on to this one. This one, we want to figure out our lowest common denominator, and it's going to be x minus 5 and x minus 1. Our non-permissible values, they are going to be 5 and 1. So x cannot equal 5 or 1. I'm going to multiply, I'm going to stick this in the middle again, x plus 2 over x minus 5 equals x over x minus 1. We're going to put these in brackets and multiply by the common denominator. X minus 5, x minus 1, x minus 5, x minus 1. So x minus 5 cancels out with x minus 5. We have our x minus 1 canceling out with our x minus 1. So on this side we have x minus 1 times x plus 2, which becomes x squared plus x minus 2x equals x times x is x squared minus 5x. Let me just double check that I did this right. And I did! So if I subtract x squared from both sides, these guys cancel. Because x squared minus x squared minus x squared, 0. So what we're left with on this side is, oh, what did I do here wrong? Oh, this should not have been an x. So make sure that you go in and erase that. So what I have here is I'm going to add 2 to both sides. So I have 2, and I'm going to add 5x. So we have 6x equaling 2. X equals 1/3. 2 divided by 6 is 2 over 6. Cancel. It's going to be 2/3. Now we're taking a look at our non-permissible values. We know that x cannot equal 5 or 1. That does not conflict at all with the fact that x equals negative 1/3. So we're good. Okay, before I go on to C, I know in my last video it was brought to my attention that I said that 2 over 6 cancels to 2 over 3. Incorrect. I just want to let everybody know that 2 over 6 cancels to 1 over 3. I know I wrote it right, but I said it wrong. Oopsies. Alright, last example. So what I want to do first is I want to factor both so I can figure out what the lowest common denominator is. So I have 7x minus 15 over x plus 3, x minus 3 equals x minus 2 over x minus 3. So when I look at that, I'm noticing that my lowest common denominator is going to be x plus 3 and x minus 3. So that means my non-permissible values are x cannot be plus or minus 3. Awesome. So I don't have to do anything, well actually yes I do. So I'm going to put this in brackets and I'm going to multiply by that lowest common denominator. X plus 3, x minus 3, x plus 3, x minus 3. This one is lovely, right? Because it cancels both the x plus 3 and the x minus 3. This one, I mean, it's still lovely, but it doesn't cancel as perfectly. Alright, so this will just cancel out to 7x minus 15 equals x squared plus x minus 6. I want to set this side equal to 0 because I want to factor this side. So I get x squared minus 6x plus 9. That's pretty sweet. I know that's a perfect square factor. X minus 3 squared, so x must equal positive 3. Awesome. Or is it? Let's double check. We said that x equals 3, right? But in our non-permissible values, we know that x cannot equal positive or negative 3. Okay? Because if x equals 3, that will bring this and this denominator down to, well, it'll bring it to 0. So that's no good. So since non-permissible value is x cannot equal positive 3, there's actually this one, no solution. Woohoo! So we did all that work for nothing!